We're going to discuss equivalence tests versus ANOVA. We're going to do it in Minitab, and it is also called 2x2 crossover design equivalence test. It's a very wonderful concept of hypothesis. Let's learn how. The case study has been given in the directly in the Minitab, and the samples also given along with the data set. So this is the one, and let me go ahead and take the sample and then I can demonstrate further. So this is the one. You can take it from the open worksheet and look in Minitab's data, Minitab sample data folder, and you can put stomachic acid. Give OK, and you will find this particular value. I will just cancel it because the same value will come up. Okay. Now let's see how we can do it. So all you have to do is you have to go to stat, equivalent test. Since we're talking about group 1 generic medicine and group 2, and then you have a brand 1 and then group 2 brand and generic. So let's see the questions more in detail. Okay, you can just click help, and this is the example is being given there, and we are going to take an example. So just click on example. You want to determine whether your generic antacid or antacid is equivalent to a name brand antacid, right? So you're gonna compare the generic and brand. Two group of participants receive 5-day course of one antacid followed by 2-week washout period, then 5 days course of the other antacid. You measure the gastric pH on the last day of each treatment. Because of the lower, this is important, because the lower pH values are more acidic. Higher values mean the drug is more effective, right? So that means lower mean it is more, that means it has a problem, is it has a more acidity, and higher refers to that means the medicine is good, the drug is more effective. You will consider the antacid equivalent if the pH value is 10 percentage within 10 percentage of the reference pH. That means the pH value should be less than 10 percentage. Okay, so this is the 2, and we are also going to give the value as minus 0.1 and then 0.1 also as well, and let's see how we can do it. So this is the, I'm just going closing this up, and then we have two options. This data is unstacked, right? And the first one is the sequence one and the period one. So we have a group 1 generic and then group 1 brand. Similarly, you have group 2 brand, okay, group 2 brand and then group 1 generic. So this the two, sorry, this is the two value we have got. So group 1, group 2, generic, and then so group 1 and group 2 brand. So we have, so even any this is multiply, even if you interchange also, it is not going to make any difference. So minus 0.1 and then you can put 0.1 and you can multiply by reference mean and have a click on options, and in that you can give the label for treatment. Label for treatment, you can give generic or brand, anything. So I'm giving generic, give OK. And in the graph, I'm gonna select all the things: subject profile plot, period plot, sequence by period, mean plot. And then result, I'm gonna keep it like method, descriptive, effects, differences, test, everything. And that will going to come up in the window session. Give OK. So a lot of graphs are there. We will just read this graph later. First, we will see what is the session window talks about this one. As you can see, this session window has nicely is given all the value. Let's go to the top. So this is the value we are talking about in so equivalence test for 2 times 2 crossover design, group 1 generic, group 1 brand, and group 2 generic, and group 2 brand we have. So this has been multiplied with this, and as you can see that mean is 4, right? And for this first one, mean is 4, and here is mean is 4.3. The second one is mean is 3.7 and 4.1, and the standard deviation is also slightly higher. And then this is the effect. The effect says that so the first one carryover is the first one treatment is 0.128. This is the confidence interval, and you can see mean of generic and reference being subtracted. As you can see, both are having impact. So that means the greater the p value is 0, that means can claim equivalence. That means when you give, so because we have referred by, you can see here generic, right? That means generic medicine is also is having equivalence also as well, right? In both the group 1 and group 2. Group 1 we have done in the previous batch, and then after that the same experiment is being conducted with a new set of patients. So this has been done. Now what I'm doing it, so as you can see here, maybe we can go further and subject profile, all that. Now we can go to graph. In graph you will be able to understand much better now. So this is the 1 0, and you can see the confidence interval, the band is here. This is a nice one. And then subject profile, as you can see, sequence 1, sequence 2, and what is the response of reference and generic. This has been compared with the generic one. And then similarly, you have a period 1, period 2, and then it is being compared with these two, right? And then the sequence by this one. This is generic and reference. Right? So now what I will do change this one to brand. Make sure that we have a same spelling and give OK and OK. Now we can see, so what is the value? Again, go back to session folder, and now we are comparing by this one. Let me go up here. Let me check the spelling of brand. Okay, we have given correctly, and you can give a session. You can go to the session folder, and as you can see that these two are can claim the equivalence in both the ways, right? And similarly, you can do the same thing. Now you can see the graph, everything, right? So this is very useful whenever you have within the group, there are two set of group, and now we are comparing it, and we are comparing with the reference and all that. So this is very useful. And similarly, the same thing, we can also do it with the help of ANOVA, very famous one, right? So what I have done, so all these value being stacked up, as you can see, for example, this is all the value for generic, and the last value 3.29, and you can see here, and then followed by group 1 brand and group 2 brand and group 2 generic. And now we have how many factors? We have 4 factors and 1 response. The response is pH value. So go to stat, and you can go to ANOVA. One way ANOVA, because we are comparing both all the values. I'm gonna give F3 so that it will clear the window. We're gonna do it one more time. And you can see here response is pH value, and the factors are type. And you can see comparison. To key comparison is very good. So you can just take it, and then you can also get it like other other graphs also as well, like individual plot and box plot and so on. And you can give OK. So I will come back to the graph later. First, we will see what is the value ANOVA, it is giving it. So you can see here, this is the ANOVA table, one way ANOVA. Null hypothesis mean all means are same, and alternate is one mean must be different. And then you can see here, there are 4 levels. That means, see, degree of freedom, we have 3. Why 3? N minus 1. So 4 minus 1 is 3. So you have adjusted sum square, adjusted mean square, F value, and P value. P value, it shows very significant, right? And we'll see which value is having more one. You can see here the group 1 brand is 4.3, and 4 and 4, and then all the means are slightly different, right? 3. So group 2 and generic is very impactful, right? Because the lower the pH value, that means the medicine is effective, right? And that's what it means. So you can see here, and furthermore you can see the Tukey model also means do not share the letter of significant difference. Okay, not a significant difference. Okay, and then you can see the p value also. P value we've already seen, right? 4.16 percentage. And this is one. And then you can go to the graph. In the graph, you can easily see, this is the brand one, group one generic, group two, and group two generic, right? We can easily find it out. And this is how we can get to know all this one. So what I'm doing it at the end, I'm going to compare all the values in one graph. So what we can do, we can go to tools, and my edit is not working. Let me go back. Okay. Okay, so maybe we can also see that individual plot, and then you can see the interval plot and other things. So I hope you find it very useful. Very rarely it is used, but it is very, very useful. Please start exploring something, an option called this one, equivalence test, and you can do it one sample, two sample paired, or two times two crossover design. And remember, it can be done. Determine whether the treatment means obtained from two times two cross over study are equivalent. For example, use a compare test. If for the medicines and all that, it is useful. Test the drug to a reference drug when two groups of participants each receive both drugs in a different order. I hope you find it useful. Please do like, share, the my channel. You have a wonderful day ahead.